what? 80 from the question that we had, 0 to 80. We're not going to consider that it's just the 40 over here. We'll consider the 0 and then the 80 as well. That is what the extreme value theorem is saying. If a function f is continuous in a closed interval ab, then the function has both a maximum value and a minimum value on that interval, closed interval ab. Note that one should guarantee that the function is continuous. One, the function is being analyzed in a closed interval. Two, the symbol a, that is into brackets ab, implies a closed interval and includes the endpoints ab. So from that question that we did earlier, the endpoints is 0 and 80, right? Whereas AB implies an open interval and excludes the endpoint AB, right? So this is just explaining what we did earlier, that we are going to consider the extreme values, not just the 40 units that we had, right? So looking at the same question here, right? We had Q to be 40 after differentiating it, equating it to 0. We had 40, that is for our Q. What to do with that? However, since the analysis is being carried over a closed interval, we need to verify the endpoint, that's the closed interval, or the endpoint, sorry. Q is equal to 40 indeed yields the absolute maximum revenue. How about the 80? How about the 0 as well, right? So we'll consider 0, we consider 40, that's what we calculated for, and we consider the 80. The closed intervals are 0 and then 80. So we'll put the same quantities here into the total revenue function. So if total revenue is equal to 0, then we have 0 here. If the total revenue is equal to quantity is equal to 0, we have revenue to be 0. If quantity is equal to 40, then the total revenue will be what? 400. If the quantity is 80, we produce all the 80 units, then we'll get the revenue, total revenue of 0. You see, it's simply telling us that after considering all the extreme values, the maximum point is at what? To produce quantity of 40 units to achieve the highest revenue. So thus, the maximum revenue is attained at quantity 40. So it means that as a producer, if you produce more, it doesn't mean you're going to achieve or attain the highest revenue, right? Application of this relative maximum and minimum, right? So suppose C is the total cost function of Q, unit of a product, where this is the what? Total cost function. At what level of output Q will average cost per unit be minimum? And then what is the minimum value? We've been given the total cost function to look for or to calculate our average cost. We know that total cost is what? We know that average cost is total cost divided by quantity. So we'll just divide this total cost function by quantity. Then we have this function over here, right? Same application on what we did under the extreme value theorem or relative extrema. We have the function now. We are going to differentiate the average cost function we have here and equate it to 0, right? So after doing that, we have this, and then our quantity will be plus or minus 40 because of the square here, and then we have a square root here, right? We are going to get plus or minus 40. And then since we can't produce negative units, right? We can't say we are producing negative 40 units, no. So it is Q is equal to 40. So to confirm whether our average cost at Q equals 40 will give us the least cost or the average cost, the second derivative test is applied, the sufficient condition. Take the second derivative of the differential, which is what we have here. If you differentiate this function over here, you are going to get 800 Q to the power negative 3. 800 Q to the power negative 3 here is greater than 0. And that shows that at that point, there is a minimum point. So therefore, the minimum average cost occurs at 40 units indeed, right? The value of the minimum average cost at Q is equal to 40 simply tells you that put this quantity of 40 into that average cost function, and then you have this 23 over here. This is also another example under relative extrema where we have to apply what we've learned. So the Visa TV company currently has 100,000 subscribers who each are paying a monthly rate of 40 Ghana cedis. A survey conducted reveals that there will be 100 more subscribers for each 0.25 decrease in the rate. At what rate will maximum revenue be achieved, and how many subscribers will there be at this rate? It's talking about maximum revenue, so total revenue, which is price times quantity, right? We don't know the number of times that this rate will be reduced by 0.25. So let's x the number of times rate is decreased, right? So you know that price is the same as the rate we have here, right? You see that if the rate is 40, it is going to be reduced by 0.25, right? So minus, right? The rate is now 40 units, or the 40 Ghana cedis minus the 0.25 decrease times x. You know the number of times is going to be reduced, right? And then we have the number of subscribers, which is also representing a quantity, right? They are saying there are 100,000 subscribers, and if it is reduced by 0.25, we have 1,000 more, right? So it is 100,000 plus 1,000x. Okay, so we can find a revenue function which is saying that it is price times quantity. Multiply this by that, and that will give us this function over here, right? The next thing is to find the maximum revenue, right? What do you do to get the maximum revenue? We are going to differentiate the function that we had earlier, i.e. this function over here. The differential of this total revenue function gives us what? The function that we have here, that is saying that the differential is 15,000 minus 500x. Equated to 0 here, we'll have our x to be 30. It means that if the rate is being reduced 30 times, we'll achieve what? The highest revenue, or the maximum revenue. But how are we sure about this? Because the company can also make the subscription free, right? So the second derivative test is going to confirm that if we reduce it 30 times, that will give us a maximum revenue. So if you take the second test, or the second derivative test on this differential, we are going to get negative what? 500, right? Negative 500, which shows that that point is a what? Is a maximum point, right? It's a maximum point. So that's at x equal to 30, the relative maximum revenue is attained. However, this is the range. So we can reduce it 0 to 160 times. So we are saying it should be reduced by 30 times to achieve the maximum revenue. But this is the range. How did you get the 160? It's just the rate of 40 cedis divided by the decrease 0.25. That will give you 160. That means that the company can choose to set x is equal to 0, meaning no reduction, or 160, that is, they charge nothing, making the subscription free. Okay, we thus have to test the revenue particularly at x is equal to 0, since it is obvious revenue is 0 at x is equal to 160. What do you do? That is the extreme value theorem. We put this 0 in place of the revenue function, we are going to get 4 million. Note that this is a revenue function. This function over here, you are going to get what? 4 million. If you put 0 there, if you consider the 30 that you calculated for, that you are saying that if you reduce it by 30, that will give us the maximum revenue, and we've confirmed that by doing the second test, you are going to get what? 4 million. Okay, plus this, and that should give you 4.225 million. Okay. So 0 gives us 4 million. 30 into the revenue function gives us 4.22 million. You can see that the 4.22 million is higher than the 4 million. Thus, the revenue is attained when the current rate is reduced 30 times, right? So if we reduce it by 30 times, we'll achieve the maximum revenue. You can try with the 162. You can put the 160 here into the revenue function. You can see that it will be less than that of the 30, or it will be less than the 4.225. Okay, so therefore maximum revenue is equal to 4,225,000 Ghana cedis. Right. This is another example on the relative extrema, which is also the application of the minimum and maximum. Right. You can also take a good time and then try this. Right. If you have any question, you can put it in the comment section, and we'll be able to help you gladly. So you can try this at your convenience time. Let's look at the final parts of the session. which is also the application of what we've learned under relative extrema. Right. Suppose n is the number of recipients of the healthcare benefits after t years, where n is in thousands of elderly people and given as n is equal to t cubed over 3 minus 6t squared plus 32t. The range is 0 is less than t is less than what? 12. At what values of t will the number of elderly receiving benefits start to fall? Right, what do? You've been given this function over here. Looking at the first condition that we learned, that i.e. the necessary condition, it says that when you're given the function, differentiate that function, equate it to 0, find the values of what you are being asked for, right? At what values of t? So we are looking for t here. Differentiate this. T to the power third or t to the third over 3 gives you t squared. That's the differential. The differential of minus 6t squared gives you minus 12t. The differential of 32t gives you 32. If you equate this to 0, either by using methods of completing squares, right, using the quadratic equation formula or your calculator, then you can get the values of t to be t is equal to 8 and t is equal to 4. That's the values of t, right? You could also use the quadratic equation formula, which is saying that to find it is minus b plus or minus root of b squared minus 4ac all over 4a, right? Where you are going to use this function over here, right? So your b is what? Is minus 12. Your a is 1 here, the coefficient of t squared. B is negative 12, the coefficient of minus 12t. And then c is the constant 32. That should give you the same values, 8 and 4 here. So the values of t, where the number of early receiving benefits will start to fall, is at what? 8 and then 4. Thank you for this session. Thank you for participating as well. I'll urge you to subscribe to this channel, and then if you have any further questions, you can put it in the comment box, right, or in the chat box. Thank you and have a good day. Meet you next time in the other sessions. Bye.